So the things I want to do, this is actually not a huge section, but I want to go through breaking, escaping, nesting, and sort of having multiple loops. So this is break, continue, else, and then loops within loops. And then there's a couple of activities to go with it. So in fact, I might as well just put these together. I don't know why I stuck it in the middle. Okay. So having loops, and we've got for loops and while loops, and quite often that as they are, as you sort of sort them all the way through so far, is enough. You go through every item, you go through every number or whatever, but sometimes you actually do need to have a loop that maybe skips or gets out of the loop earlier than you expected, or earlier than the full all the way through the range. So how do we do those things? Well, let's have a look. For I in range 100, let's say we're looking for the first number that is a multiple of two other numbers, right? So the first number that is a multiple of 5 and 7, right? Now we could work out that fairly easily, but let's say we're going through the loop, we want to actually just check everything that's there. So what we can do is we can see, well, if I mod is the remainder, 5 is equal to 0, so there's no remainder, which means it's divisible by 5 evenly. So 5 would work, 10 would work, 15 would work. And I mod 7 is equal to 0, so that will match 7, 14, 21, and so on. So if it's both of them, then we're going to do something. So and
plug that in the charger. My battery's dead.
So we can do this. Now, I'll just run it as it is first. So let's go to the terminal. Let's put in the answers bit. Yeah. So it just found 0, 35, and 70. Right. So those are three things that fit that description. Well, first of all, definitely didn't want it to find 0, so let's get rid of that. It's finding 2 of them, right, which is what I actually intended it to do. But I don't want it to find 2. I want it to stop at the first one, because this might be a hunt through something that's very different. It might be, does it exist in here? Is there a number in this list of things that meets this requirement? Okay, as an example, or a record in a database. So let's say, this is a slightly more difficult problem. We might have values equals list range 10,000 items, right? Now, we definitely don't want to have to go through the entire list when we could have just found it way up at the top. Okay, here it's just a bit of math, so it's not like it's taking a lot of effort, but it could have been. So it could be worse. We might not even have the value in there, and we want to be able to tell whether we found it or not. So we'll start with it like this. How can we get out of this? Well, use break. Let's put a print done at the end so it's nice and obvious. F35 done. Okay, so now we haven't gone through the entirety of the rest of the list, and that's really handy. So that's break, and what break does is it breaks out of the loop that it's inside. Okay, so if you've got more than one loop, which we'll talk about in a bit, it breaks out of the one that it's inside, the nearest loop, the innermost loop. Okay, so the other thing that we might do is we might want to actually do some sort of calculation on these things. So we might say, right, for all of the numbers that are divisible by this, we want to do something with it. Okay, so let's say we wanted to do something like if it's this, then we're going to, what should we do? And we'll do something else with it.
Could you make the text a little bit bigger, please?
Yes, I can do. That big enough?
That's brilliant.
Okay. So I'm using a trick to do this without bothering with the library. So something to the power of 0.5 is the square root of something. It's just a easy way to do it. And double star, if you remember, is to the power of. So like 2 squared would be 2 star star 2, or square root of 2 would be 2 star star 0.5. Okay. So what we're going to do is we're going to go through and we're going to calculate, you know, these values and do some stuff. And we might have, you know, lots of processing that goes on. That's not what I meant to do. Yeah. Now, that's going to take time to process. Not very much, but we can imagine it's a proxy for something that does take a long time. And so what we might want to do is to skip over any that don't do it. So at the moment, it checks and then goes around the loop. But we could split this around and we could do some processing, and then we could skip if we wanted to. So what we could do is we could say, if this is not true, continue, as in skip the rest of the loop and then do this. And now we don't have all of our complicated stuff inside here. We just have a continue, which means skip over the rest of it. Okay, now this is just a bit of syntactic sugar. There's no situation I've ever found where you have to use continue. You could always just put stuff in an if statement so it doesn't execute otherwise. But if you compare it, so that's how we are now. We check. If it's not what we want to do, skip the rest of the loop. If it is, we carry on. That's fine. As it was before, everything that we want to do is inside this if statement. So what we do is saying, if it's this, do this, but if not, do nothing. And so what we're looking at is a loop that looks like it does this, but actually only does it under certain circumstances. So it really depends what you want, you know, to the code to look like. They both do the same thing. Let me just get back to where it was. Okay. So we've got, it's not the number we want. We just skip, otherwise you do it. So let's make sure it still does the same thing. It's not the one I want. There we go. And it does. It does the same thing. And we're only pressing the ones that we want to. So that's just some dummy examples of break and continue. They're the kind of thing that you can live without quite often, yeah, but it makes things a little bit easier and simpler. They're useful a lot when you want to skip over things. So you maybe do some processing and then, you know, you think, actually, for this one, I'm done now. Let's just skip the rest of this loop. So you might have up here, squares of things, and only if it's a multiple of both 5 and 7 do you do square root. That's fine. I'm not going to do that again. There we go. Okay. So you can see square of everything, and for some of them you also get the square root. So it's just a way to structure your code. So that's those. Oh yeah, we also have, and this is where I personally think that Python is particularly good at these things, is we can have an else. And this is where I said we've got more complex examples to come along. So let's go back to something like this. Okay. Okay. So we'll run this now. It finds that the 35 and it runs. What if there weren't any? What if none of them matched? The way you do this quite often in other languages, you'd say something like match is equal to false, and then here you'd put match is equal to true, and then you say if matched, so if it's true, do this, or if not matched, okay. So if I had, instead of this, I had a list that goes up to 34, which means I'm not going to find any. Okay, so it's not found. If it goes up to 35, so it definitely does find one, then 35, it's up to but not including. That's totally intentional. defines one. But actually now I've got a new variable, I've got all kinds of things going on. Well, there is another way to do this, okay? And that is you can have in Python an else attached to a loop, okay? And what that does is it executes this piece of code that's indented here only if we didn't break out of the loop, okay? So we get the square root and it's done, or if it doesn't exist, found, okay? Which is a lot neater and doesn't require an extra variable to run. So that's the else part. Last things I wanted to show you are nested loops. So I'm going to demonstrate this, and then I'm going to leave you with the last part is for you to try this. It's one of the challenges for you to have a go at, so you can have a crack at this for yourself. But I'm going to show you now how I would do it, and then you can have a go for yourself. So I'm going to try and do something that's going to draw a square of stars. Okay, so something like this, yeah, same number across and down. So first of all, I'm going to have a variable. I'm going to call it size. Let's say I'm going to start with 4, and then I'm going to say for I in range size. What we get. Okay, you can probably guess that this isn't going to be exactly what we want, but yeah, let's try it anyway. Python and this. Okay, we get 4 stars, but we want more. Also, we want to draw them in rows. That's the easiest way to do it. So really, we should go back to our accumulator concept and say each time, and then afterwards print the output. There you go. And then if size is bigger, more stars, right? So that's a line of stars. Now we want to do this, but we want to do it size times. So what we do is we make another loop and put it inside. So J will be equal to 0, and then I will be equal to 0, print a star, then I is 1, 2, 3, 4, and so on, adding a star each time. And then J will become equal to 1, and then I is 0, then 1, then 2, then 3, then 4, all the way through to size. And then J is equal to 2, and then I is 0, then 1. So it just repeats the inside. One last thing I need to do to make this work is I need to make sure I put a new line character, so it goes on to the next line after each row. So once this inner loop is done, and add the new line character, the /n. Hopefully, we get a, well, it's a square in the sense it has the same number of stars one way and the other. It's not a square because the star character is not actually taking up a square amount of space, but you get the idea. So 14 one way, 14 the other. If that was 5, it's 5 by 5. Okay, so that's the nested loops. The example or the challenge that I wanted you to have a go at is somewhere. Did I not put it in? Oh, because that's not the one. In iteration. Whoops. There we go. So you've got countdown. Have we got this one? It's very simple. Square of stars and triangle of stars, which is the slightly more advanced one. So you've seen this walk through, but give it a go for yourself, and then see if you can make it work with the triangle. Okay. Now for the triangle, you're going to need to use some data from the outside loop in the inside loop. I'm not going to show you the answers to this one because I want you to try it yourself. What I'm going to do is I'm going to show you that we can actually put some information inside that depends on the outside. So let's change this now to something completely different. We've got our nested loops. I'll put size back in. 4. Something. So what I'm going to do is I'm going to try and relate these things to each other. Okay, so how do I do that? So J is equal to size, I is equal to this. Well, inside here, I have access to I and J. So and you get all these things multiplied by each other. So we can actually refer to those values. And what that also means is that I can use that value in here, right? So there we go. So I times j is 0 times 1, 0 times 2, 1 times 2, 0 times 3, 1 times 3, 2 times 3. So what's going on? Well, the inside loop is going up to the number of the outside loop. So in the first instance, it goes up to but not including 0, so it never executes. So you don't get a 0 times 0. Then when it becomes a 1, it changes around the other way around. In fact, it might be easier if I change these values the other way around. Still works, but it might actually look
Not quite, because that's it. You got it.
So 1 times 0, 2 times 0, 2 times 1, 3 times 0, 3 times 1, 3 times 2. So you can see 1, 2, and 3 on the left, and then the right-hand one goes up each time. So first of all, it starts with the zeros, and then you get the ones and zeros, and then you get the 2 in as well. So you could always go say, this plus 1 if you wanted to make sure you always get the 1 in there, and so on. So you can make the loop variables not independent, right? So this one goes for up to, but not including the outer one, whatever it is at the moment, plus 1. So the first time round it goes up to 1, second time it goes up to 2, and so on. Whereas the outer one is 0, then 1, then 2. Okay, right. Those probably seem like really contrived examples, and they sort of are. But what you need to do is to look at the ways that you use those when you come across more complex challenges. So the square of stars and triangle of stars, these are sort of just there to test you out. As we go through, you're going to start seeing places where you need to use this. So from next week, you're going to start using this to generate password attempts. Okay, so loops within loops. And you'll see a lot more use for it. So it's worth practicing those simple things now, and then next week you'll start applying them.